Welcome to Winbond Talk. I'm Thomas. Today we are going to talk about low power consumption. Why this topic? Because we've seen a growing adoption of wearable devices. People are asking how to lower the power consumption. Today we are pleased to have Will from Winbond here to talk about this topic. Welcome, Will.
Hello everyone, I'm Will. I'm the PM of Winbond Fresh team, also in charge of the low power consumption product line.
Hi, Will. I believe that the development of low power consumption is not new to the industry. Every supplier must have their own solution, right?
Reducing power consumption has been one of the goals that every system designer is looking for. A power-saving design can prolong the battery and also minimize heat dissipation or cost. From a single component point of view, power consumption can be reduced by optimizing the process and the structure of an internal circuit. From a system point of view, we can change the operation mode, such as reducing the duty cycle via one of the CPUs or using software further to achieve power saving.
So in a system, every component needs to be energy efficient. Does Winbond Flash bring any certification intended for low power consumption that is more competitive in the industry?
The operating voltage of today's flash memory ranges from 1.8 volt to 3 volt. Simply put, if you want to save power, 1.8 volt flash is a better fit. If you don't need a power-saving design, 3 volt flash is good enough. The same idea can also be applied when choosing other components. But looking at memory's evolution, the operating voltage has become lower. It's apparent that designers are aiming for further power saving. Winbond is the first in the world who introduced S-piano flash at 1.2 volt.
Understood. You are the first in the market, but if 1.2 volt is not the standard, will customers buy it?
Initially, we worked on 1.8 volt flash, trying to reduce the current to minimize the power consumption. That is the result of voltage multiplied by current. Having said that, we found that the scheme was not effective in reducing the overall power consumption. Thus, we embarked on the development of reducing the operating voltage. In order to minimize the voltage without compromising the performance, we had to develop a new process, a new circuit structure. With the view to reduce the voltage as much as possible, we set the center voltage at 1.2 volt, so the next generation of SoC can run on such voltage. But Thomas, you're right, 1.2 volt is not a standard voltage in the industry. But our core design concept is to align with the leading chipset suppliers. There is no standard for innovation. Standards are defined for the followers to comply with.
That's great. It seems like customers are willing to pay for this. What are the target applications of Winbond's 1.2 volt flash? Could you elaborate more? And how much power consumption can this 1.2 volt flash actually reduce?
Regarding application, it works well on a device powered by external battery, like TWS earphones, smart bracelets, watches, glasses, and other wearable devices. As to power consumption, if compared with 1.8 volt flash, 1.2 volt only consumes 55% of power.
Wow, it can reduce 55% power consumption of 1.8 volt flash. However, wearable devices have strict requirements not just only for power saving but also cost, right? Could you tell us more what extent is Winbond's 1.2 volt flash cost competitive for the system?
Let's see from a simpler application like smart bracelets, for example. The use of 1.2 volt flash can simplify the power management design of a system. By replacing the power supply to flash from a PMIC to a LDO, this transition can save roughly 66% of component cost and 15% PCB space. Reducing PCB space is another way to reduce cost, and the freed up space on a PCB allows for more flexibility in product design.
So, power saving and the cost reduction of the system are two major advantages that Winbond 1.2 volt flash shows. Besides, what makes this flash different from others?
The biggest challenge of reducing the operating voltage lies in the fact that performance is compromised. For example, flash read speed is often reduced. To overcome this issue, we have developed a circuit structure totally different than before to maintain the performance to the same level as 1.83 volt flash. The read speed can reach 104 MHz.
So, power saving, cost reduction, and uncompromising speed are the top 3 advantages of Winbond 1.2 volt flash. We are glad to have Will to talk about this topic today. This is the end of today's Winbond talk. See you next time. Bye bye.
Bye bye.